right. Hello, hello. I've got this talk, web application pen testing. It's not just checklists. After I was talking to a friend of mine, he said pen testing is boring because it's all just checklists. Going through testing for XPath, SQL injection, HTML injection, just walking through long lists, checklists, and so on. That is not my opinion of web application pen testing. So I put together this talk to basically showcase methodology that helps pen testers find vulnerabilities that are not just checklists, vulnerabilities that are, well, not discovered by anyone before, vulnerabilities that are, say, undefined at the moment. I want pen testers to approach an application from, say, a point of view where you don't need to know about every single vulnerability to be able to test it adequately. I have some ideas that I hope you will find useful. My name is Chris Dale. I am a principal SANS instructor. I teach for SANS. I've been doing so for 10 years plus, and I'm also the co-founder and CEO of a pen testing company called Cybersecurity, where we do all kinds of exciting stuff such as offensive security operations centers, always-on pen testing, attack surface management, and frankly, it is great. I have a little list of certification, etc., but in short, my primary skill set is incident response, throwing the baddies out again from customers, and also showing customers how they get broken into. In other words, pen testing. I have a background in software development, IT operations, security management, and also now, well, building a cool company. We are 3.5 years old at the moment. I'm in Brussels right now teaching a class on daytime, and I'm doing this extra stuff in the evening for fun because I love you all, I love the community, I love our industry, and frankly, it is really exciting. Cybersecurity, 13 people at the moment. We are homegrown, no private equity, no venture capital. It's a great company to work with and tons of great people working with us. So check us out. Anyways, let's begin my presentation. So, web app pen testing. Why this talk? Because, well, to be honest with you, web applications are everywhere. Right now in this room, I'm sitting here with my 2 laptops. There's a projector, there's a webcam, and so on. And I bet you that there are more web servers in this room than just my 2 laptops. There's probably a web app on the projector. I'm sure I can remotely control the web app in some kind of, the projector in some kind of web app. Absolutely certain. Maybe even some of the lights in the room have web apps. Web apps, probably a web app on the heating and ventilation control panel. It is ubiquitous. My laptops have several web applications running right now. VMware, for example, can be remotely controlled or administrated with a web application. So definitively, web apps is a great place to be. It has a huge potential in terms of like return on value that we can provide to our customers. And the learning curve is not that steep. It is not like, say, reverse engineering, exploit development. It is easier to get into web application security if you ask my personal opinion. Many people do consider web apps to be boring. I'm going to make it become less boring. I'm going to take sexy back into web apps. They are really awesome when you understand them and when you get into the testing. Also, there is a lot of opinions within pen testing. The Dunning-Kruger effect, where people who don't necessarily know that much think they know everything because, well, they don't know that much. And as, well, they start to learn more and more about web apps, they realize, wow, how little they really knew. There is a lot of potential inside of web apps. There's lots of hidden attack surface, lots of opportunities to find 0 days, CVEs, and so on. So this talk hopefully will shed some light that there's more to web apps than what might meet the naked eye. Also, it is a great place to be in. So, many of you have heard of the OWASP Top 10. And yeah, we need a pen test that tests for OWASP Top 10. Let's test for injection. Let's test for this and that and blah-de-blah-de-blah-de. OWASP Top 10 is great, but it's not a single source of truth. It is the most common vulnerabilities, but that doesn't mean you shouldn't test for something else. In fact, Portswigger, my heroes over at Portstrigger, they created the Portstrigger top 10 attacks. For example, number 7, worldwide server-side cache poisoning on all Akamai edge nodes. Wow! Do we understand that technique? Can we employ those techniques against our customers? Not just Akamai, but maybe we can learn something from that. What about, for example, psychic signatures in Java, or dirty dancing in sign-in OAuth flows? There's just so much potential in web apps, a lot more than what meets the naked eye, and I hope I will make it engaging and interesting for everybody, basically via methodology that will help you find interesting use cases. This talk might be a little bit long because I want to walk through our methodology that we use at Cybersecurity, share it with you so you can build your own. So let's see what we got here. Click the button, change slide. There we go. First of all, the tool of choice when testing web apps is going to be a browser and a proxy, a local proxy and an attack proxy that can help you automate script and find and help you have control over things. I'm a big fan of Burp. The commercial edition is amazing. It has all the features that I need to make stuff happen. I need to be able to have a proxy log. I need to have intercepting proxy to be configurable. I need to have a sitemap. I need to have a vulnerability scanner. I need to have extensions. I need a very detailed log of all of the work and scanning activity that we're doing. Burp is just simply amazing. It supports a lot of fuzzing requirements that we have. For example, I need to fuzz for bytes. I need to fuzz with Wordlist and so on. In all, it is amazing. Great spidering support. It has been developed quite a bit over the last few years, where we now support spidering and crawling, discovering contents on single-page applications. It is not perfect yet, but the crawler or spider, as it is in its current state, will do things like clicking on buttons and seeing how the document object model works and changes, and basically help you build out that sitemap. It is a good starting point. So I very much like Burp. You should check it out. If you need a free alternative, there is a community edition of Burp that you can use. It is decent. It doesn't have the active scanner. That means vulnerability scanning. It lacks a lot of the extensions that you want to use. It also will be throttled. That means that it will slow down the speed when you fuzz things. But again, it is free. Another free alternative is OWASP Zap, the send attack proxy, which kind of looks and feels like Burp. It's nearly there. To me, it doesn't just feel right. I have used Burp for so many years, I forgot to count. I'm no longer counting. So I just love it, okay? It's a nice tool. I've also created cheat sheets on Burp. So be sure to check out the cheat sheets to get some information about, say, how you can use Control-R to send to the repeater so you can quickly repeat requests, Control-I to send it to the intruder so you can quickly start fuzzing, how you can URL decode, encode, and all kinds of tricks and tips in the bag for you when you're using Burp. So that's a cheat sheet that I got out there. Some of the most important extensions that I recommend you look at is first ActiveScan++. It will extend your vulnerability scanner with some extra nice to have checks. I recommend the \power scanner, which will cause a lot more false positives when you're scanning and doing vulnerability scanning, essentially. However, the false positives are things for us to investigate and discover if it's a vulnerability or not. \power scanner looks for transformations of data. It will basically try to automate finding anomalies and discrepancies for you. As such, creating more false positives, but really, if you have the skills necessary to do web application pen testing, you should be able to conclude those false positives, and hopefully, many of those findings from \power scanner will lead you into interesting paths, potential vulnerabilities, potential questions for your customer, and more. We got the paraminer, which is super helpful in discovering what we call unlinked parameters. Say in a URL you have the get parameters, and we want to discover if there's any get parameters, say like admin equals 1 or has credentials equals whatever. We want to automate that discovery of unlinked get parameters, headers, and cookies. And Paraminer does a really good job, high performance, in discovering when a parameter makes the web application change so that it can single out those parameters that are most interesting. Nice to have extensions. Turbo Intruder is nice for automating your attacks, testing race conditions, and doing large, fast attacks across an application. Lots of potential in the Turbo Intruder. On their GitHub, there's also some examples and demos of the Turbo Intruder, so be sure to check that out. We got the software vulnerability scanner, which is nice in terms of finding if there's CVEs, common vulnerabilities and exposures, basically potential vulnerabilities in the software that you have found on the web app, like libraries and so on. We got the collaborator everywhere, which is used to basically add what we call the Burp collaborator in all kinds of headers and so on to see if you can make any external server interaction. If you can make the server or something between you and the server, like middleware, cause some kind of callback, like a DNS lookup, a HTTP lookup, SMTP, it could be anything, and the collaborator allows us to, well, find that kind of data. So the collaborator everywhere adds it everywhere for us, so we can use it as part of some of our testing. And then we have authorize, which essentially allows you to test an application with and without sessions, with or without authorization. So you're logged into the application, you click around, and some of those features that you click around into might be available from an unauthenticated point of view. Authorize helps you automate the testing with and without credentials so that you can get a report that allows you to zoom into the details of, say, missing authorization faster and quicker. There's also all sorts of extra extensions as well in Burp Suite. I'm not going to go walk through all of these. There's a lot of them. Some are great, some are no longer maintained, some are new and should be checked out. So I recommend that you go into the extension overview in Burp Suite and check out what kind of extensions they have. Now, let's move into the methodology, shall we? So the methodology that I've built together with River Security is an upside-down pyramid. This pyramid contains from where we spend the most time, more or less, down to where we spend the least amount of time, or where like the final parts of the process is, and that's going to be the tools. We start with content discovery, we move into fuzzing, we move into hypotheses and test cases, business processes and logic flows, and then we might have frameworks that allow us to test for certain things, and finally we got the tools at the end. This methodology is what I will be walking through for us in this YouTube video. I'll walk through what each of these steps mean. I will indicate or help you understand that you might need to go back. I will tell you that you might start running tools in the beginning, and that's fine. As long as you don't skip the previous steps, we're going to be okay. I wanted to build this methodology to make sure that the attack surface, the application, is thoroughly discovered so that you leave no stone unturned. You must find every possible entry point to the application. Otherwise, there could be some super low-hanging fruit available to another hacker that you failed to find because you didn't do a good job content discovering, for example. I also want to encourage team-based efforts so that it's not a solo pen test, but instead you work together with your team when you're doing your pen tests. And I want to make sure that we have a strong knowledge sharing and building of test cases and hypotheses together with the team so we can make each other stronger during our pen tests. Solo pen tests, you do that pen test, you do that one, and then let's meet in 2 weeks and basically start something new. I don't like that approach. I want us to collaborate more. So that's going to be the methodology. Let's move into content discovery first. The goal is to find absolutely everything. We cannot allow ourselves to have scripts or functionality that we just missed out on, that we didn't find. We need to ensure that we map all browsable attack surface, that we find as much unlinked content, say hidden scripts and input parameters and so on as possible, and for each, basically do this for each different part of the application. Imagine that an application has different platforms. When you access the application from one point of view, you will see that it runs on this kind of stack, like a middleware, and when you access it from another point of view, you might be reaching into other parts of the application or a different stack. So I'm going to zoom into that here in a second. So find as much attack surface as possible, and what you might discover is that the vulnerabilities that are the most juicy, the most interesting, are the ones where the path is least traveled. Those places that nobody else managed to find. Those places that have some old debug functionality, some admin functionality that hasn't been maintained or updated in forever. Those are the really interesting places where you could strike gold, essentially. So let's take a look at platform distinctions first. So an application has different users going into it. And maybe you access the application via some kind of middleware solution here, some reverse proxy, a load balancer, or something like that. Or just maybe you have a server that has different deployments, or it hosts an application that have a wide different application code based on where you navigate in the application. You want to discover such distinctions, because you need to repeat parts of the model based on what part of the application you're hitting. Say maybe if you go to the /users with some get parameter, for example, you might be sent to one part of the application that is responsible for the user behavior. But if you go to the / of the application or help, you are actually sent to another part of the application. So in such cases, it becomes important for us to ensure that we do thorough testing on each platform distinction. Not only just scripts and endpoints and so on, but we need to do things like guessing of folders and directory and files, guessing parameters, and so on for each platform distinction. So what we do first is, during our content discovery, we have an objective to map everything. We want to browse the entire application. We want to click, use, discover as much as we can find by just using the application, and perhaps equally important, to learn, what does this application do? What is the meaning behind these functions that I'm using and clicking through? When we do all of this work, you will see that we will find a sitemap, or we will build a sitemap that allows you to have an overview over, say, your progress in the pen testing, and also an overview of the functionality that exists. The Burp Suite crawler is pretty good, has been upgraded, as I said. It will help you build the sitemap, but don't solely rely on the crawler, okay? The spidering or the crawling feature of your attack proxy, your Burp Suite, and so on is a complement or a supplement to your process. You need to also do manual content discovery based on how you know the target, based on what features you believe it to be exposing, and so on. We need to apply intelligence to the content discovery. You will also find that modern applications have a lot of JavaScript, lots of references to, well, things that could hold more functionality. So when we have JavaScript, say, for example, in a single-page application, Angular, React, Next.js, etc., for those JavaScripts, first of all, you should understand how they're used. Say in a Next.js application, there's a lot of JavaScript, which is for the framework and for basically you using Next. But some parts of the JavaScript is actually for the application, which has been coded by your developers. Those JavaScripts, we should make sure that we extract all file paths and references, perhaps even study it a little bit to make sure, do we understand what's going on here, and to make sure that we grab all of those API paths and file and endpoints and so on that this JavaScript could be referencing. It's a way to help build out the sitemap. So there's a couple of tools that you can use. We have, for example, JS Parser on GitHub. You've got plugins like Gap. But to be honest with you, I'm a big fan of Cyberchef. And Cyberchef has an extract file path module, which is pretty good. So you could beautify the JavaScript, and then you can extract file paths, and you can scroll through it and make sure that you leave no stone unturned. Then we are going to continue with our content discovery methodology or process. We want to find unlinked content. So we want to make sure that we take, say, every function and verb and see if we can find more functionality inside of an endpoint. So we have, say, for example, say, action equals show user and an ID equals 123. In this case, we have a function that we can fuss, the action. We got the ID we can fuss, and to see if we can discover more. And we have a verb we can fuss, show user. If there is a show user, well, who knows? Maybe there's an add user, delete user, hide user. You don't know necessarily until you have tried, especially when we're typically coming from a zero knowledge type of point of view. If you have access to the source code, good for you, that will help you. You should also consider using wordlists to help you discover more, say, verbs and functionality in the application. There is a lot of built-in wordlists into Burp Suite that will give you a solid starting point. The ones that I like to use is called server-side variable names, form field values, and form field names. You add all of those word lists in your little Intruder tool, for example. You click deduplicate, and now you have several thousand words that could give you some solid indicators if there's more functionality or not. Also, we should use and create word lists based on what we learn about the target. A word list will be a list of possible words, possible things that represent this company. Those kinds of word lists are really useful to help us, well, build more targeted word lists that could find more content and functionality for us. Say, for example, we have a website which does something with PDFs, right? PDF files or zip files or whatever, heating and ventilation, it doesn't matter. Whatever concept this website is all about, think about that for a second and see if you might be able to build a word list on it. In this case, I am running basically grep on a huge repository of tons of word lists that my company have built, that we found online and so on, that we're using and managing and so on. I'm using grep. I'm saying, hey, I want to look for anything that, say, starts with PDF and has any characters following, right? I go through all my word lists, and I want to have any word mentioning anything with PDF, just because you never know. There could be some interesting words in many of those word lists. So that's a way to, well, rapidly generate a new word list on the fly. Here's an example where we're looking through, so fuzzing verbs, we're looking through an application trying to see if we can find more functionality. And we have a little URL that indicates a get parameter page equals 872. All right, I wonder what happens if I fuzz that parameter. So if there's page, maybe there's something called query page, step page, search page. Who knows? We don't know until we try. So in this case, we are basically using the Burp Intruder to go through the website riversecurity.eu, and we're fuzzing the keyword before page. We are trying everything before page. And just like that, when we put in debug page, we get a different content length than the others, and that could mean that, hey, there is such a feature called debug page that could give us relevant information as pen testers. There's also built into Burp Suite and many other open source tools, content discovery. So instead of doing all of this yourselves, you can you can support yourself with automation. And the content discovery feature of Burp Suite is decent. What you will do is you will right-click on the platform distinction, whether it's the slash or whether it's the help or admin or whatever. You right-click, go content discover, and you can then say, I want to discover files and directories. I want to recurse a certain level down. Consider taking this default value down from 16 to maybe 2 or 3. And then you want to say, I want to use the built-in word list that is in Burp Suite. You would want to use your own custom word lists on the left here. And also, you want to, based on names observed on a target site and derivation based on discovered items, you want to see if you can find more stuff based on those items. This is extremely useful. Also, what Burp Suite will do is it will take anything that you found and see. Say, for example, if I have admin.php or something like that. Well, is there an admin.sql, admin.zip, admin.back, and so on? So we got these extra options that will help us test for more stuff in an automated fashion. And most of the time, you won't find nothing, but what if you did? And many times we do. So you find something, for example, called CSproj. All of a sudden, you have a Visual Studio project on your hands. The developers deployed the application, forgot to clean out the project files, for example. That could give you extremely valuable data. So these are just good advice and ideas. We should also remember that we can cheat. If we can't cheat, we should. We are working for our customer, trying to provide the highest value possible. So, for example, if our customer has Swagger documentation or Open API specifications, we should ask for such specifications, meaning that the developers and the organization is basically handing us a recipe of every function, every endpoint, every input parameter that they expect the users to submit on. It will describe their API, for example, so you don't have to guess as much. We should still keep on guessing with our content discovery procedures, but if the developers have this documentation, in my honest opinion, they should hand it to you so we can jumpstart our processes and make sure we don't miss out on anything. It's all around a good idea, and down here we have an example Swagger JSON file that allows us to see that, hey, there's something called pet. It accepts post, put, and get, and the get parameter here, the get method, takes in a find by status. We can put in a pet identifier on this one. All of this is extremely useful for us as pen testers, so we can make sure that all of the functionality is thoroughly tested. In terms of finding unlinked parameters, we should try for every platform distinction to see if we can find more parameters that are not intended or not necessarily documented or referenced or linked by the application. So we should try get, post, cookies, and headers. We might find that there are headers that could bypass authentication and so on. We might find more attack surface. If we don't do this, we could be missing out. That's why we like to go in and see what more we can find. We love the tool or the extension Paraminer. In fact, we tend to love anything written by James Kettle or Albino Wax on Twitter. Anything he builds for Burp Suite, he also works for Burp Suite. However, anything he builds seems to be of high relevance and high value. So in this case, we're using Paraminer, the extension, to help us out discover more parameters. And in this case, for riversecurity.eu, the website of my company, we found multiple secret inputs in the URLs and in the headers. So we can see that based on this finding, you can see that when we give it the X requested with header, we have a different number of words, we have a different number of scripts, we have a different content length than if we tried the header X requested with and a random string. That means that this X requested with has an impact on the application. It has a function. When you provide that header, something happens. Meaning, heck, we need to test it. We need to figure out if there are vulnerabilities in it. All right? Good. There are also other cool things we can do during content discovery. Before we move into fuzzing, I want to give a shout out to some things we could do. We could go to archive.org and we can look at their archive of the internet and look at what a website looked like in the old days. Here we are looking at the sans.org website back in 2001. Why would we do this? Well, maybe some of this functionality, maybe some of the old stuff is still enabled on the website. Old scripts, old content. It could be, so the website has been through many iterations since then, but it could be that some of the older stuff is still available. And that old stuff, well, it could have vulnerabilities. Naturally, we're not going to be able to go through the entire archive.org for a domain and fetch out every single endpoint. That's why we automate, and we use scripts like wayback URLs that will produce a list of all the endpoints that you could find on archive.org, and wayback robust.py, which goes through the robust.txt file and gives you more endpoints that you can automate with the Intruder to see, does this stuff still exist on the website? You could get lucky. All right. Next up, we have fuzzing. So content discovery, very important. And there are more things to talk about in terms of content discovery. But I mean, we only got about an hour for this talk, okay? Fuzzing. Fuzzing. We want to make sure that we can discover vulnerabilities, not just by scanning it with a vulnerability scanner, but we can actually discover what there is to find from a pen test knowledge, not just some automation that somebody else built. So for every script and input, we should send that script and input, meaning get parameters, post parameters, so on, to the repeater, and keep clicking Control Space and keep sending those messages after you change certain names and variables and values and so on. Explore the script. See what you can learn. What does this script intend to do? So that when you start to hack it, you have some ideas how it's meant to behave and how it currently is behaving when you give it special characters and attacks from Wordlist and so on. Once you have done this, you then move into the fuzzing phase. You take the input and you should at minimum fuzz every single character from 00, that means byte 00, all the way up to the bytes FF. So you need to go through how does the application or the input work when I give it an A, a 9, a null byte, carriage return, a semicolon, a tick, a double quote, parentheses. We go through 256 characters just to make sure what happens when I give it something different. This fuzzing in Intruder gives you a nice little overview and some interesting feedback if data sanitization is in play, or if the application just behaves erratically or differently, anomalous behavior when you give it certain special characters. This is quite valuable because if we find any anomalies, it means that you can now go ahead and explore, say, certain classes of vulnerabilities or see if you can build on that attack. Maybe you find that, say, a tick makes the application redirect you back to login, or a double quote or something like that. Your job is to ask, why? What's going on here? I didn't get an error message from the database or nothing. I just got a redirect. So you go back to the script with your fuzzing. You take those interesting characters and you fuzz again. Maybe use a word list. Maybe use the vulnerability scanner. Or maybe fuzz again every byte 00 to FF. See what happens when you give it a tick and then maybe a semicolon, dash, dash. Who knows? You might be onto something here. So we're trying to engage the pen tester's brain and intelligence into trying to solve actual problems instead of willy-nilly trying to run some scanner. So you find some anomalous responses. That's when you use scanners and tools and so on. When you find some anomalous responses, you continue excuse me, into building hypotheses, implement some attacks. If you cannot figure it out, if you cannot understand why the single tick, why the double quote, why whatever characters is producing anomalous responses, you engage your team. You ask somebody else, maybe somebody with more experience. Hey, Chris, why does the application behave so weird when I give it these characters? Something up, some vulnerability, and so on. That is pretty useful. And the process has been lined up on my left side here, or maybe it's your right side. But anyways, on the side of the slide here, you will see that I've lined up the process on how to think about going about doing such things. When you fuzz the bytes, what you do is really you set up a fuzzer or an entry point. You define like the input to be numbers from 00 to FF. You prefix with a percentage so it becomes URL encoded. that URL encoding will make sure that your data passes through the middleware and lands inside of the application, okay? So that you don't necessarily send a null byte because you might break something in between, but you want the null byte to be encoded so that it lands in the actual application you're testing. If you add a URL decode on the data, which you can do in the payload processing part of Burp suite, if you add a URL decoder, you will notice that, hey, you are now not necessarily targeting just the application, you are also targeting things in between you and the application. Maybe a load balancer, a reverse proxy, a web application firewall. There could be interesting stuff there as well. So if it's in scope, be my guest. Test all you want. It is typically quite interesting. And you will see that stuff on the network behaves weird when it receives certain characters, like line feeds and so on. All right. I think we covered this slide for now. Important thing is when you're done with an endpoint, or when you're done with, say, the application, say, what's your name is the application. My name is input Chris. So my name equals Chris, right? I fuss it, and I don't find anything. You should not just fuss it. You should also fuss it with bytes. I mean, not just fuss it with bytes. You should also use a word list based on your experience or based on the target type, based on what the application does. And also, you should send that specific input, what's my name equals Chris, that input should be sent to a vulnerability scanner to help you conclude, to support you, so that just in case you missed out on something, the vulnerability scanner gives you a second chance, and if the vulnerability scanner finds something, we need to go back to our methodology and make sure that the next time we test, we are able to find that vulnerability, that we are able to find what automation could find, right? We don't want to rely on just a scanner. We want to make sure that the pen tester has the tools and steps necessary to find such things on their own, not relying on somebody else's scanner. I hope that makes sense because it's quite important. Here are two examples. So I've lined up some Burp suite flow up here. You set your payload positions. You select the attack type, and you got some cool sounding attack types in Burp suite. For example, you got the sniper attack. Woo! And what the sniper attack is, really, you go through one payload for all of the target position. So say a word list or an attack for every position that you have defined. You have the clustering bomb, which means that you can define multiple payloads, and for each payload go through the rest of the payloads like a for loop, nested for loop. So a for inside of a for, nested for loops is what the cluster bomb does. We have the pitchfork, which allows you to define multiple payload positions and multiple payloads, and it will go through each payload for each position at the same time. So it's kind of like a pitchfork that just stabs with each payload over and over until you have exhausted all of your payloads. The pitchfork has many different use cases, but I will not talk about that in this talk. I would rather do a dedicated talk on the Burp suite and so on, because there are certain examples with cross-site scripting and other things where this can become quite useful to test. And then we have the battering ram, which just simply takes a payload and rams it into every position that you have defined. So let's see. Here we have an example. I have an application that when I send a request to it for something that shouldn't exist, asdf.aspx, the application replies with internal server error, 500. Is that what you expected? For sure, it wasn't what I expected. I expected to see a 404, page not found. Anything that I put in the get up here, anything that I tried to look up with an ASPX extension, just fell on its face, crashed, and burned. 500 internal server error. I wonder why. That's the questions we need to ask. What's up with that? You know, could there be a vulnerability here? Who knows? We gotta fuss. We gotta test. So I define my payload position inside of asdf.aspx. Maybe in front, maybe in the back. It's up to you. So I have my intruder, my fusser. I define the payload, and I fuss every byte from 00 all the way down to FF like this. And I noticed that some of the inputs that I give the script, or I make the web server look up, %25, 26 down to 3f here, when I give it such inputs, the application, well, behaves differently. I get a different content length. Rather than 2325 number of characters coming back, number of bytes, I only get 2179. Again, the question is, why? Let's take a look at those URL encoded bytes. 25, for example. What is %25? That's a percentage. When you decode it, it is a percentage sign. 26 ampersand, 2a star, 3a colon, greater than, question mark, less than, and a plus. Those characters makes the web server behave differently. Well, let's build out some hypotheses and try to understand why. If you cannot on your own, engage your team members, right? The percentage, ampersand, question mark, and plus all belong to URL parsing. URL, so how a URL is defined. Percentage has to do with URL encoding. The ampersand is to delimit get parameters. The question mark is to indicate that now is the beginning of input to the application, get parameters and so on. And the plus represents a space. So maybe those are okay. But what about the others? A star typically represents a wildcard when we're talking about file handling. And that's what we're looking at here, right? We're looking for a file so the web server can run content on it. ASDF.aspx did not exist. But the star, well, it returns different behavior. Interesting, considering it has to do with files. The colon on NTFS represents which this server is running off. It's a Windows server, so it's likely going to be NTFS. The colon represents alternating data streams. Which means that a file can have other files inside of it. Check it out. It's a pretty cool feature of NTFS and REFS, the Resilient File System. Anyways, that's cool. The greater than and the less than symbol indicate redirect operators, where we can redirect into files or from files and so on. So all of these inputs have something to do with files. Hence, we need to employ tactics and techniques that help us find file-based vulnerabilities. You engage your team, you engage your word list, you engage your scanner and so on, and you look to see if I can maybe read a local file from the system. Maybe you can read remote files from the internet. Maybe you can put things into other files. Maybe you can read, say, the web.config file. Who knows? We need to explore. Here I have another example. We're fuzzing for bytes, 00 to FF. And one of these bytes, well, causes a significant different reply. Not on the status code, not on the time it took for the request, but again, on the bytes. Most of the other bytes return 1101. This one here returns 1263. So you inspect the one with 1263. When you give it a backslash, all of a sudden the server says, warning, MySQL number of rows expected parameter 1 to be a result, and it was given a Boolean. Strange. We broke SQL, meaning we have most likely SQL injection in this case. And this is, in fact, SQL injection because it's from a CTF, an online war game called overthewire.org. That is overthewire.org. And it has a large collection of war games. One of them is called Natas, and it's all about web application security. I totally recommend it. So let's see why this camera is not following me anymore. What's up with the camera? Hey, don't chase my shadow. See my hand and follow me, please. These cameras are stupid. They embed automation and scripts to track me as I'm moving around. But I like to teach with my hands. So all of a sudden, the camera gets a signal from my hands that says, stop tracking. Sorry about that. Anyways, I hope this makes sense to you. And when you do this kind of fuzzing, very thorough kind of fuzzing, you will notice that there is a lot of rabbit holes. And rabbit holes will take up a lot of your time. I will cover rabbit holes soon, but when you deal with rabbit holes and so on, try to think that Occam's razor's principle, among competing hypotheses, the one with the fewest hypotheses is often correct. The simple solution is often the correct solution. So while you might be deep inside of a rabbit hole trying to find some kind of super interesting zero-day, something super interesting that nobody has known about before, it could just be a simple explanation to the problem. So always explore those things first. Cool. All right. In order to avoid rabbit holes, there are some tricks. So what is a rabbit hole first? It is something of interest. Ooh, shiny. This could be a super interesting vulnerability. Except, in order to research it, it's going to take a long time, and it could be a dead end. It's going to be hard to research the vulnerability or the potential exploit condition. So to avoid rabbit holes, but still be able to conclude them, what you should do is, in my opinion anyways, take a note of the rabbit hole. Let your team members help you on a rabbit hole. While you prioritize width and make sure that you cover a solid baseline of testing on all of the endpoints and inputs, and then, if and when you have time, you go deep into the rabbit holes and you exhaust all of them, making sure that there are none potential exploit conditions left. And that might require a team effort, okay? Also, we should structure your work scope when you're working on a web application. You should consider splitting up each platform distinction between multiple team members so that you can work together on a pen test. All right, you take the /help, I'll take the /all other things, for example. And consider how much duration you have on engagement, how many hours you have spent on engagement, and how much time you can spend exploring those rabbit holes without it being a loss for your company. Ideally, you would explore all of the rabbit holes, exhaust them completely, but as you know, our companies also need to make money, so we can't spend necessarily 2 months researching something that looks interesting, but could just end up with not being that valuable. My 2 cents on that topic. In terms of using word lists, this is rather important. You should be collecting word lists. There's a bunch of them online that you can go look at. SecList, for example, on github.com, Daniel Mazer, SecList, lots of great word lists. Download them, and guess what? Open them and study them a little bit. What does this word list try to do? What's this kind of a string? Why does this try to attack a command injection? Try to build up some knowledge. I would also note that AssetNote, see what I did there? They also have a wordlist.assetnote.io subdomain containing a large list of automatically generated word lists based on technology and many other things. They are great help. Now, the word lists that we generate in Cybersecurity, we make sure that we understand them and also that we flag them based on what type of data they contain. In fact, we have these PH and UE identifiers on the word lists, where PH means that this word list expects, or it has a placeholder. Maybe the word list needs a domain, like an external server interaction type of domain. Maybe it needs some kind of IP address or something. That is indicated with the PH argument so that you can open up the word list before you use it and make sure that you replace the placeholder with actual values that will make the word list work. And then we have the keyword UE, which indicates if the word list is already URL encoded or not. And based on your fuzzing results, you will select your word lists based on that. What did the fuzzing tell you? What is the likely scenarios and so on? Of course, you could paint the application with every single word in every single word list. That will take up a lot of bandwidth, time, and effort. So typically, we want to single down our word list to what we believe might have the most impact. Here's an example where we have placeholders, and we use the Burp collaborator to... Where's the camera going? All right, I think we're good. I'm just going to double check the stream here to make sure that it is actually good. Yeah, it's following me. It's okay. I guess you can see me. It's a bit dark in the room, but I wanted you to see the slides as well. Slides will be online as well after this talk. But many of the word lists, as I said, they will require some kind of external server interaction, for example. So we want to replace the word lists with a Burp collaborator, or if you want to use the free version, interact.sh, so that we can see if our word list makes the target behave differently. Say, all of a sudden it makes a DNS request to us, makes a HTTP request, all of that stuff we must measure, and Burp Collaborator is a tool that will listen for callbacks, listen for that external server interaction. So we go through the word list, we use the string replace feature of Burp Suite, and we replace it with our unique URL. Like you can see in the screenshot here, we have found that our host name, this random string that Burp has given us, received DNS requests from these IP addresses, and then subsequently they received HTTP requests from these IP addresses. What should you do then? Well, you should feed them some content, right? If they're making an automated HTTP request to you, what happens if you feed them cross-site scripting, bytes of all kinds of sorts and so on? It is a super interesting avenue to explore for penetration testers. You should also know how to build good word lists, because you will not be able to just download word lists from everybody else. You need to build your own in many cases. So a friend of mine from Aske, outside of Bergen, where I live, Roy Solberg, he has created a tool called Cooler based on DigiNinja's Robin Wood's tool Cool. Cool is a Ruby script that generates word lists. Cooler is a Python script that generates word lists. And in my honest opinion, Cooler is a bit more up-to-date and better if you ask me. There's also extensions like the Gap extension of Burp Suite and so on that will allow you to help build word lists based on your target. There is word lists like the HTTP disallow entries for Cisco Top Million. There is URL shorteners, brute forcing results that you can look into. Wikis is a great source of building word lists. So I got some scripts on GitHub that will take in data and produce word lists based off them. But say, for example, I've noticed that my target is very obsessed with Disney characters or the Flintstones or asteroids, bacteria, whatever it might be. I got word lists for such cases, and I will build those word lists for languages, for specific domains within a country, like Norwegian soccer team, municipalities, and so on. These are all word lists that are quite useful. And when I'm building these word lists, so here's Gap up here, the plugin up here. It will try to do it automatically for you. It's decent. It had some problems with it, but it's decent. What I like to do is I like to use the Linux command line. So I'm on Windows, but I just type bash, and via WSL, the Windows subsystem for Linux, boom, I'm on Linux. Beautiful. I will grep for, say, anything starting with API-co. I will convert every uppercase character to lowercase. I will sort and unique it, and now redirect that output into a new word list for API-co, for example, and so on. So that is what I like to do. Now, there is also plugins that will help you scan, and these plugins we talked about, but essentially after we are done with our fuzzing, when we have defined input parameters for our fuzzing, when we're done fuzzing them, we should also send them to the vulnerability scanner, right? Make sure that those input parameters get that second opinion so that we can hedge our bets to make sure that this application is safe. And we talked about this quite a bit already, but if the scanner finds stuff that you didn't find via your methodology, reconsider training, reconsider methodology, reconsider your process, so the next time you can find them without relying too much on automation. Another thing we do in our fuzzing, before we move into the next part, is reviewing our logs. So the logger within the Burp Suite is now, the native logger is now pretty good, okay? I used to use an extension called Logger++, but as Burp Suite is improving, the logger built in now is rather good. So once we are done with a script, we've fuzzed it with hundreds of thousands of requests potentially, what we then like to do is go into the logger, sort by status code, and at the very least, filter on 500 error messages. Why did the application reply with these 500 error messages when I scanned it with the vulnerability scanner? So I will see what the scanner is doing. I will see that the parameters that the scanner sent in and so on. And my job is to interpret why those inputs cause the application to crash on its face and provide an error. And sometimes, as you step through all the 500s, you find something interesting, and you go like, looks like this input caused something interesting to happen, a crash scenario or something, and you can maybe then take that input and build on it, change it, and see what else you can find. Once we're done with the script, I right-click and I wipe out the logs, so I now have a fresh log for the next script that I'm going to start with. And that is rather quickly walking through the fuzzing methodology, or the fuzzing part of the methodology. And yes, we could spend hours talking about it. It is more in-depth and detailed, but hopefully this gives you the right ideas how pen testers can start to provide higher value in their pen test engagements. Next step is hypotheses and test cases. So hypotheses are important for the pen testers to consider. They should look at the application and ask themselves, based on my experience, based on the application, what could be plausible attacks in this application? For example, maybe the application allows me to reset someone else's password, right? I have a password reset form. All right. If I have a password reset form, fuzz it by all means, scan it by all means, but you need to apply your knowledge and experience to ask yourselves, maybe I can redirect the password email somehow, the password reset email. I've done that before. Yeah. Host header poisoning. I managed to send in a host header belonging to a domain that I control. When I sent a password reset email for somebody else's user, I received that email. Hijacking accounts, essentially. Maybe the password reset email doesn't have high enough randomness or entropy. Maybe we could guess other people's codes to the password reset process, for example. Maybe we can predict some values, or values as it says on the slide, is a typo, but predictable values, who knows? Maybe this application here that you're targeting, you suspect that the input that you give it is being passed down to other applications. Maybe it's written to some database and then read by somebody else. Well, maybe that means that you need to do extensive cross-site scripting testing. Maybe you're allowed to put JavaScript somewhere, and as long as that JavaScript makes an external server interaction with your machine somewhere else, you can learn that my JavaScript would actually, run somewhere else at a later time. That could very well be. Maybe in a logging application or something like that, your data, your attacks gets logged, admin logs onto the logger 2 days later, clicks the logs, boom, sees your JavaScript, executes it, and hey, you won. Maybe there's delays when you do certain actions. All of a sudden, when you click the button, all of a sudden the application, it just loads for a couple of extra seconds. Your job is to ask, why? Wonder what's going on here. Do they do any server-side requests? Do they do any processes on an operating system? Why did it take so much longer? And then you try to build out test cases that will help you test more scenarios. Maybe there is a state machine within the application, which most applications do have state. Could we influence the state somehow with race conditions? James Kettle, again, has just recently on Black Hat, or was it DEF CON, announced some really awesome research in terms of race conditions. They have updated Burp suite to enable better and quicker testing of race conditions and so on. So that is just some examples of things we should test. But really important, don't do this just on your own. Piggyback on your team. Set yourself up with a 5-minute stand-up meeting. Say, hey, I got this application. It does this, so and so and so. I have these bytes that are interesting. I have these interesting functions over here and here. And anybody got some clever ideas? Anything we can do together to make sure that we can properly understand the vulnerabilities of this application? So utilize your team. Make sure that you can work together and try to properly work out the hypotheses. Explain them well. And if you can't do it on your own, use the team. So sourcing rabbit holes to your team members also we talked about, and essentially ask for help. That's what I really, really want to stress here. Then we're moving into our final parts of this presentation, business process and logic flaws. All right, business processes. Let's take a look at the logic of the application. What is it doing? What's the purpose of this application? Can we maybe make it break from a logical or business perspective, right? Think about it not just from a technical perspective, but what does this application really do? So maybe we can produce some test cases, like maybe we can break into other tenants by, say, abusing some kind of feature, some kind of function. Maybe we can find process flow breaks if we say, maybe we need to go through step 1, step 2, step 3 to buy a product from the web application. Maybe we can put something in our cart, update the cart. Maybe we can check out, add our payment details, and so on. Well, what happens if you update the cart, remove the cart, go to payment, go back to the cart, add something? Does something break? Does it work? Maybe you add things to your cart, you add one item to the cart, you go to the checkout, but then you auto add, maybe in a race condition, 100 items to your cart at the same time you do a checkout. Does that allow you to pay for one item but receive 100 items? Such questions are important to ask ourselves and see, can we test for them? Maybe if there are files being uploaded, maybe these files can contain malware. Is there any anti-malware on the server? Will they allow you to upload, say, an ICAR file? Will you be able to upload PowerShell scripts, source code? Can you overwrite the target web server's web.config file or any, say, config file? All of a sudden, you might have an opportunity to hijack the entire server. And it's important for us to, well, take a bird's eye perspective on the application and consider such scenarios before we end our engagements. Here's also a quickie on authentication, because very often we need to do the test as just a regular user, or in some cases also unauthenticated, right? But you know there is an admin account somewhere, and they don't necessarily want you to use the admin user when you pen test application, because the admin has all kinds of features that are just inherently insecure. Maybe you can write stuff to the website and whoops, there's a cross-site scripting exploit. Maybe you can, say, change files, say on WordPress, you can add and edit PHP files, so that's like an instant remote code execution. So they don't necessarily give you the admin account. You get a normal account. But what I do every time for my customers is that I tell them, hey, I will pen test as a normal user, but I want you to give me an admin account so that I can do content discovery, crawling and spidering. I need to map out everything, all the features I need. So, as an admin, I can find most of the features, and I can then test all of those features as a less privileged user, and also from an unauthenticated point of view. That is extremely useful, because what if there's a privilege escalation vulnerability? What if there's broken object level, broken function level access or weaknesses in the application? What if some parts of the admin panel can be accessed without any credentials? Well, you need to know that those features exist, first of all. That's why we map from admin, we test from regular user, and also make sure that all the endpoints and functions are not accessible from an unauthenticated point of view. If they are, make sure that you test them thoroughly. So there's also some good ideas on making flowcharts, essentially. Draw.io or diagrams.net are free applications that allows you to draw out flowcharts like these, for example. Mapping out flow of, say, authentication or behavior or process of the application is extremely useful for you to get a better grasp on how to attack this application. So there are lots of flows that when you put them on a flowchart or inside of a little diagram, you can much easier realize where the different test cases are, the different hypotheses that you should explore. Say, purchasing flows, authentication, impersonation, privilege escalation flows, password reset flows. These things are so much easier to understand when we map them out. Then we have frameworks. And this is rather interesting. There are a lot of frameworks out there, many whom I'm sorry to say they suck. They are old, no longer updated. They started out as a great idea. However, they should not be used for pen testing web applications because they are horrible. Many of them try to conclude, you need to test all these things, all of this stuff, SQL injection, test for command injection, test for local file inclusion, test for server-side request forgery, and they don't allow the pen tester to test outside of, say, vulnerabilities you don't necessarily know about. So frameworks can be challenging if you use them not as a guide, but if you follow them step by step. However, frameworks can be useful when they are a supplement to your pentest methodology. And there are different frameworks out there, and the framework that I will talk about is, so I want to do first an honorable mention to OWASP and application security verification guidelines. Those are really good for pen testers to study, and some customers will ask you, hey, we need an an application security verification guide test on, say, level 1 or level 2 on our application, and you will support them in doing so. Sure, ticking checkboxes. That's not bad. It is not really the worst, but it is not enough. What we do at River Security is that we have what we call minimum viable pen test methodologies. So for any technology that we test, say if it's a 403 or 401, 403 unauthorized header we get back, so we're not authenticated, we have a methodology for that. For APIs, we have a methodology for that. For ASP.NET Web Application Firewall Evasion, we have a methodology for that. Auth0 authentication. For web application proprietary technology, for generic functionality, we document and document based on the experience we built. And the minimum viable methodologies here, these MVPs, are essentially, this is the absolute minimum you need to do when you're testing the application based on previous experience. That way, we don't always have to start fresh on Google, Stack Overflow, Hacktricks, XYZ, and so on. We can start with knowledge that we have built ourselves. Say testing WordPress, right? You got to do a pen test on WordPress. Is it really useful for you to test the WordPress engine, the source code of WordPress that runs the entire blog? Hopefully Automatic, the people behind WordPress, do their own pen testing, and hopefully there's tons of other eyes on the project, so the vulnerabilities in the core are being vetted and found over time, all right? I don't think your customer wants to spend a lot of money of you testing tens of thousands of lines of code of the WordPress engine. Yes, I found WordPress engine vulnerabilities before. It's not like they don't exist. I've had bug bounty payout from Automatic on WordPress. Regardless, that is most likely out of scope. What would an MVP describe, though? An MVP would describe that on WordPress, it is imperative that you check plugins and extensions to WordPress. You must enumerate themes and plugins so that you can test and see if they are vulnerable, weak, and so on. The moment WordPress contains custom functionality, we start to drool a little bit and it goes, woo, super interesting, you know? Also, we need to engage with the WordPress API. We need to ask for all media file uploads. We need to ask for all users that are on the system. And we need to thoroughly explore the WordPress. That's what we would define in such an MVP. These are the steps that, based on our previous experience, we require every other pen tester to do. This is very useful because, say, for example, I did an SAP test, SAP, and I document the MVP based on my knowledge that I've learned, my research, and so on. By deploying technology before I go on a pen test, I can research from a crystal box perspective. Maybe I can run some Docker containers, some virtualization. I can experiment, build up some attack techniques. I document that, so next time we have an SAP pen test, I don't necessarily have to do it. My coworkers can do it, probably just as good as I did, because they can learn on what I did, and they can do it on their own, with their own knowledge and own experience, okay? So it's a nice way to share information and so on with the team. We want to make the pen testers accountable to at least check the things that need to be checked on that specific tech, and also ask the team to help build out such MVPs when they are not already built. Ideally, we would want to have a day or two before we work on a pen test to carefully look at their technology and set up the stacks ourselves so we can build an MVP before we start pen testing on something that we don't know. Some other things to consider. So, this is also in regards of the MVPs. We got technology-specific and application-specific MVPs. So we want to make sure that we test the entire stack. We want to test the middleware. We want to test the web server. Most of the time, we're concerned about testing the managed code. That's good. But we also might have backends involved, and we want to have MVPs for as much as possible so that we find the interesting vulnerabilities. Say, if the web server is running on IIS, for example, Microsoft's web server. Those web servers are by default, in most deployments, vulnerable to something called IIS short name scanning. And if you didn't know this, well, you should have known it. And we have an MVP that says that if you target an IIS web server, you at minimum must check out IIS short names. It's important. And then for application specific, say for example, I'm testing Craft CMS. There are lots of debug options in Craft that you should explore if they're there. There are several log files and Wordlist that are extremely useful when testing Craft. For example, with ArcGIS, there are ways to discover if there's points of interest or sensitive map data that could be exposed without the customer necessarily knowing and so on. So we need to build out these things. And in terms of testing frameworks, I would shout out again to ASVS. It is a nice guideline. Just don't use this as your entire kind of playbook. And when you don't have the MVP, we create one. It is minimum viable. It doesn't mean that it's the only thing you do, but at minimum, we need to do this. So you start building, you set it up, you break and you hack it, configure it so that you can get some experience before moving into your customers' deployments and start to hack their applications. We do this all the time. My coworker Vega, principal pen tester, he has all kinds of applications running that represents different application tech stacks and so on, so that he can explore them from a crystal ball perspective. And he finds vulnerabilities all the time because of it. So that is really good and nice. Maybe even you get some experience. For example, I needed to explore Azure functions. Functions in Azure, because my customer had several of them deployed, and I had no idea what I was doing. So what did I do? I set up my own Azure function. I configured it. I deployed my code. I intentionally made it vulnerable, and I saw that I could break it. And then we did something nice. We released it to the community in form of a capture the flag, so that other people could also learn how some of these functions could get broken into. And then finally, we get to the tools. And we're nearly done with this talk now. Tools. Well, it depends on what you have. Depends on what you target. There's so many different tools, and the tools you use will be based upon whatever you're trying to hack. You might use IIS short name scan. So this will abuse the IIS vulnerability that I was talking about, where we can brute force the 6 characters of a file and the first 3 characters of an extension. So for example, here we're brute forcing inside of the folder metadata card. We find that there's a file called metadata_1, and metadata_1 has an extension .zip. So in this case, I want to discover whatever that -1 is. These are short names, and it's a feature of Windows that enables you to represent files with short names. I need to find that file. That zip file is incredibly juicy looking. And in my case, it was just metadata_card.zip. So yeah, we found that file with no previous knowledge. We brute forced every character from A, B, C, D. We found something on M. Then we went into A, M, C, M, D, M, F, and so on. Skipping parts of the alphabet there, I heard. But still, we found ME, MET, and so on. Beautiful. And that tool is for IIS, so it depends. Here we are using a tool that I will soon release a version on GitHub. But we have a WordPress scanner. We go through all of the WordPress information and see, can we find something interesting? In this case, the script returns users, and it returns media uploads on riversecurity.eu. And sure enough, down here, we have a media file upload called secret.txt. And of course, you don't want to miss out on that. on that. I got some research on this topic coming up. Hopefully within October, November, perhaps December, I'll have published a nice tool and also lots of research on WordPress and how horribly insecure it can be if you don't know what you're doing. There's a tool for pretty much everything. Whether you like to use Nikto, Nuplay, SQL Map, doesn't really matter. Collaborate with your team, have a repository and a knowledge base of nice tools to use in different scenarios. Maybe you're targeting Magento, so you use MageScan. Maybe you're targeting a JSON Web Token, so you use maybe JWT tool. It depends. And the tool comes last, right? Or maybe you could employ the tool sooner, but it's not the most important thing. Important to note. The most important thing is that the pen testers do their best hacking, not whatever tools they decide to run. And that, ladies and gentlemen, was my talk. Alone here in a room in Brussels, where I teach from 9 to 5:30, had a hamburger, recorded a YouTube video that I'm putting up online tomorrow, and then a couple of hours later, had a beer, and I decided to do this talk for you as well. I hope you liked it. I will make sure that the slides are up here on intobio/Chris Dale. You're welcome to add me on LinkedIn, follow me on Twitter or whatever, and connect with me. I enjoy having people not being strangers. So come say hi, whatever it is. Check out my company. I'm very proud of it and so on. So yeah, it's been real. Thank you for listening. I hope you stayed the entire duration. I know it was a long one. Sayonara.